we have this recorded. Okay, so we see that what we have here is a quadratic equation. We can tell because we have the square on our variable, the exponent is 2. And I'm certainly not going to solve this using the completing the square method because the number in front of the y squared there is the leading coefficient is 5. We usually only use the completing the square method when our leading coefficient is 1. So therefore, I'm going to put it in the standard form by getting it equal to 0. This will give me 5y squared minus y minus 1 equals 0. And I'm going to use the quadratic formula to solve this. Let's just write the quadratic formula over here. It's negative b plus or minus the square root of b squared minus 4ac. That whole thing is over 2a. This is an extremely important formula. You must know it by heart. There's no, for any other math class that you will ever take, you will need to know that formula. So commit it to your memory. Don't leave it in your calculator. Don't leave it in your phone. Commit it to you. Leave it in this computer up here so that it's handy whenever you need it. Okay, so therefore, we're going to write out what we have for A, B, and C. Now, my A is the 5. That's the number in front of the y squared. The B is, well, there's no number in front of the y, so that's a 1. So it's negative 1. And the C is also negative 1. Don't forget to include those negatives as part of the coefficient or those numbers. Now we're going to take these values and stick it into that equation. So it's going to be negative b, so it's going to be negative, negative 1. There are two negatives here because the b itself is negative, plus or minus the square root of negative 1 squared, that's b squared, minus 4. Here's my a, it'll go in the first parentheses, is 5, and the b, and the c, I'm sorry, is negative 1. And this whole thing goes over 2 times 5. And of course, the big thing here is once you've been careful to include all the numbers in the formula to make sure that you simplify properly. So this is going to be a negative, and a negative is going to give me a plus or a positive 1. Now let's see what's going to come out here in that radical. Let's work it over here. Negative 1 squared is a positive 1. Negative 1 times negative 1 is positive 1. Don't forget, you're squaring a negative number, it will come out positive. Then we're going to have negative 4 times 5, which is negative 20. And negative 20 times negative 1 is plus 20. So the number inside the radical turns out to be 21. This is where most of the mistakes are made. People make mistakes with their signs all the time, and that's where you're going to have to be extremely careful. This is all going over 10. Actually, in radical, you can't simplify. The next thing is to look at the radical and see if you can simplify it. And you can't do anything with that 21 in terms of simplification, because the only thing 21 you can break 21 into is 3 and 7. Neither of them are perfect squares. So this is my answer in simplest radical form. 1, and you could write it separately, 1 plus the square root of 21 over 10, and 1 minus the square root of 21 over 10, or you could write it this way with the plus minus sign. I didn't ask you to do this, but just for the sake of being able, making sure we can do something like this, sometimes we'll be told something like, find the answer. Let's say they ask, find the answer to the nearest hundredth. They might say the nearest hundredth, they might say the nearest tenth, whatever. In other words, they want the answer to be in decimal form, not just in radical form. If that is the case, then we've got to take this radical 21 and figure out what it is in decimals. And that's where your calculator is going to come into play. You can't do this without a calculator, unless you've got all of the numbers of the square roots memorized, which I don't know anybody who has, but it could, I guess it could be. So let's look. Since they want this to be the nearest hundredth, which is 2 decimal places, the numbers in the interim, I'll go one step further. I'll go to the nearest thousands. I'll go to 3 places. So I'm going to the square root. Again, if you don't know where to do where to find the square root on your calculator, just send me a picture of your calculator and on email, and I will reply with how to do it on email. Or alternatively, you can come on to class before 10 o'clock and I'm here, and you can show me what your calculator looks like, and then I can help you with it in person. But you must know how to do a square root on your calculator. I'm doing the square root of 21, and what I'm getting is 4.583, because the next number is 25. So I'm going to 3 decimal places here, and then I will do 1 plus 4.583 over 10. That'll be the 1 plus the square root of 21 over 10. Now, when you do this, you have to do it in 2 steps. First, you do the 1 plus the 4.583, which of course will give you 5.583. And then you divide it by 10. You have to combine the numerator. First, get that answer, and now do divide by 10. And your answer comes out to 0.5583. And we want it to the nearest hundredth, which means we want 2 decimal places. So we only want, if we want to stop after this 5, the next number is an 8, so this will become 0.59. The other answer, here's my other answer, we'll do by doing 1 minus 4.583 divided by 10. Again, on my calculator, I'll do 1 minus 4.583 and press enter or equal to get negative 3.583 divided by 10. Don't divide it by 10 right away. You have to do it in 2 steps. And now divide by 10, which gives you negative 0.3583. And again, we want to stop after 2 decimals. So my final answer is negative 0.36. Oh, I'm sorry, this is 5, 6, not 5, not 5, 6. You make this one bigger. So my two answers in decimal form, again, you'll only do this when it specifically tells you to do this to the nearest hundredth or the nearest thousandth. More likely to have to do something like this in a science course than in a math course. In a math course, we really are perfectly happy to have the answers in radical form. But every so often, you're asked to do something in decimal form. You should know how to use your calculator to convert something from radical form to decimal form. Okay, so this was a good review of solving a quadratic equation. Remember, if it's not factorable or you're finding it hard to factor, you can always rely on the quadratic formula for any quadratic equation. All right, I want to go back to the last thing that we were talking about on Tuesday, and that was what the graph of a quadratic equation will look like. We talked about one type of graph. I told you there are going to actually be 4 types of graphs. It's not like a linear equation where everything turns out to be a line. When you have a quadratic equation, when you have something with an x squared or a y squared in your equation, when you graph it, it's going to give you different shapes, not straight lines. I'm going to leave that quadratic formula on the board because occasionally we might use it, so it's good to have it handy. All right, we talked about a shape called a parabola. And we said the basic equation of a parabola is going to be in the form ax squared plus bx plus c. That's the y equal to that. In other words, you're going to get y alone, and you're going to have a term with an x squared. You might have a term with an x and a c, but you'll definitely have an x squared, because if you didn't have an x squared, then it wouldn't be a quadratic equation, and therefore you'd be right back to a straight line. Again, the y is not squared. There's no y squared. There's just an x squared, and the shape of the parabola is U-shaped. Sometimes it opens up, sometimes it opens down. And we said when the A is positive, I'll put an A as a plus, then we have an opening up parabola. In other words, something that looks like a smile. And when the A is negative, then we have something that looks like a frown, an upside down. So that's one of the things we talked about. We talked about finding what's called the vertex of the parabola, which is also sometimes called the turning point, because it's when you have a U, you have a place, the bottom of either the bottom of the U, or if it's upside down, the top of the U, the place where it changes its direction, that's called the vertex. And we can find the x value of the vertex by doing negative b over 2a. You have to know what the a and the b is, just like you had to know it when you used your quadratic formula. You're not going to use your quadratic formula here because we're not solving an equation in this case, but we do use the a and the b to find the vertex. Once you figure out what the x value of the vertex is, you then take that number, let's say it comes out to be 2, and you replace in your original equation your x with the 2, and that'll give you what the y value is. You need both the x and the y because a vertex is a point. So that's one of the things you have to know how to find. It's probably the most important point of the parabola, and you find it using this formula. The other things we talked about were intercepts. And in general, intercepts are talked about in terms of every single type of graph. There's an x-intercept that you find by letting y equal 0. And very often in terms of a parabola, you can have two x-intercepts because it's not a straight line, it might curve over and hit the x-axis again. And then there's the y-intercept, that's where it's crossing the y-axis, and that's when x equals 0. There's always one y-intercept. There might be two, or there might be no, or only one x-intercept. Well, the x-intercept, they're different possibilities, but there is always one y-intercept. As a matter of fact, it actually is equal to the c in the quadratic equation. And if you have these values, the vertex and the intercepts, you can get a very nice diagram of your parabola. So let's look at I'll do an equation and then I'll give you one to try on your own. Okay, so let's do this one. Suppose I want to do a graph of the equation y equals negative x squared minus 4x plus 5. Okay, so we're going to work and we're going to see how we can use these values, figure them out, number one, and number two, once we figure them out, let's look at what the graph is going to look like. So the first thing I would like to do over here is figure out what the A, the B, and the C is. Just like I did that when I was going to use the quadratic formula, I'm going to use it when I want to graph or find the features of the graph. Sometimes a question on a final or on a multiple choice won't be graph the parabola, but it might say, what is the x-intercept? Or it might ask, what is the vertex? So you have to know how to figure out those values. So it should be obvious that the number in front of the x squared, which is the A, is -1, which is telling me also that this is going to be a parabola that opens down. My A is negative, it's frowning. My B is -4, and my C is 5. So if I want to find the vertex, I'm going to have to do x equals negative b, which is -4. I'm using this formula right here, over 2 times -1, because my A is -1. Again, negative b, so -4 divided by 2 times A, 2 times -1. Well, this is not so hard to figure out. Negative and negative give us +4 over -2, which gives us -2 as the x value of my vertex. Don't say your vertex is -2. It's not complete. We now have to figure out what the y value is. And we do that by sticking this number -2 in for the x. So it's negative, be very careful here, -2 squared. There's a negative outside, and then the -2 is going to be squared. minus 4 times negative 2 plus 5. Now, when you're figuring out something like this, yes, you could put it into your calculator, but if you do, make sure you put in those parentheses. Otherwise, the calculator will, if you don't put it in with the calculator, it'll see negative 2 squared. It'll think you're doing negative 2. We want to first square the negative 2. So negative 2 times negative 2 gives me positive 4. And then there's a negative in front of it. So that first term becomes negative 4. Then we have negative 4 times negative 2, which is positive 8. And then there's positive 5. And adding these all together, negative 4 plus 8 is 4 plus 5 is 9. In other words, the vertex is the point negative 2, 9. So that's the first thing we see. Again, if you notice, the thing that we're being very careful about is those signs. If you can do it in your calculator, but be very careful about putting in parentheses. Otherwise, the calculator won't understand what it is that you want it to do. I'm going to go over here and look at what that's going to look like to start out with. Here's my X, here's my Y. 1, 2, 1, 2, 3, 4. Okay, so my vertex we said was at negative 2, so 2 to the left, positive 9, so that means go up 9, and it's right over here. This is my vertex. The vertex is going to be the high point of this graph because this is one that's going to be opening down. It's going to be what we call a maximum point. The next thing, so this was the vertex. Now let's work on the intercepts. So first, pick, let's say we want to do the x-intercept. So then we're going to have to let y equals 0, which will give us 0 equals negative x squared minus 4x plus 5. And I'm going to bring everything to the other side because this is a quadratic equation and I always like the x squared to be positive. So bringing everything to the other side changes all the signs. So it'll become a positive x squared, a positive 4x, and a negative 5 equals 0. That's, I don't think I have to show more than that. I think everybody can figure that what I did over here. I just literally transposed everything to the other side by changing the sign. And using the AC method, I think this is going to be factorable. My AC is going to be negative 5, and my B is positive 4. So I'm looking two numbers that are going to multiply to negative 5, which means one's going to be positive and one's going to be negative. And when I combine them, I'm going to get positive 4. Well, the numbers that multiply to 5 are 5 and 1. And obviously, we're going to pick the larger number to be positive because the B is positive. So it's going to be a positive 5 and a negative 1. So this gives me x squared plus 5x minus 1x minus 5. When I write this in terms of expanded to 4 terms, so I can use the grouping method, x times x plus 5. And the next group has a common factor of negative 1. And that is also x plus 5. so that this factors to x plus 5 times x minus 1. And when we set each of these equal to 0, I'm going to get x plus 5 equaling to 0 will give me x equaling -5. And the x minus 1 equaling 0 will give me x equaling +1. So my x-intercepts, I'm going to have two x-intercepts. One, and the x-intercept has the y0. So one x-intercept is -5, 0. And the other x-intercept is 1, 0. Remember, when you have an x-intercept, the y value is 0. So here, 1, 2, 3, 4, 5. Here's one x-intercept. And here's my other x-intercept right here at 1, 0. In terms of, let's just do, I think we have a little bit of space here. To find the y-intercept, we let x equal to 0. And if I put x into the 0 into my equation, this is going to be 0. This is going to be 0, and I'm going to be left with y equals to 5. We've also mentioned all you really have to do is look at the c value. The c value will be the y-intercept. So my y-intercept is 1, 2, 3, 4, 5 right here. Actually, it should be written 0, 5. You can either say the y-intercept is 5, more accurate is to say 0, 5. On the x-axis, the y is 0. On the y-axis, the x is 0. And now I can very easily draw my parabola like that. If for some reason you would want more numbers on your parabola, you could pick any of these numbers between -5 and 1. You could pick x to be, let's say, -4, pick it in, put it into your equation, and it'll give you a y value, and that'll give you another point on the parabola. I usually think it's enough to find the vertex, absolutely important, and then the intercepts. And if you can find all of those, then you get a good picture of what your graph is going to look like. Okay. I am now going to give you an example to work on while I take attendance. I'm going to erase this so we have some room to work on. I'll leave this information on as a guide. All right, let's say they did this. See if you can find the vertex and the intercepts, and if you have time, then sketch it. Okay, as I said, I'm going to erase the rest of this because this is using up too much space and making everything very messy. Okay, so I want you to find the vertex, the intercepts, and sketch this graph. It's parabola. All right, Jesus Antonio. Jackson Avila. Hi, good morning. Tiffany.
I'm here.
Hi, good morning.
Hi. Angelica, she said that she can't make it today due to personal reasons.
Who was that?
Angelica?
Okay, thanks. Thanks for telling me. Tell her she could just, I tell her I did record it and she can watch the recording if she has time.
Okay.
Caleb Brantley. Tashana Caesar. Hi, good morning. Dion.
Morning, I'm here.
Good morning. Wensley Charlemagne. Tatiana Collins. Hi, good morning. Awa yeah, good morning. Ashay Douglas. Hi, good morning. Eliana Stay. Emily Gomez. Anastasia Guerra. Zenabu Hamed. Ismail.
Here.
Hi, good morning.
Morning.
Jaden Jackson.
Here.
Good morning.
Good morning.
Ashiana Jacobs. Anijah John. Thomas John.
Okay.
Hi, good morning.
More.
Paul LeBron.
I'm here.
Good, thank you.
Morning.
Good morning. Ashley Moorhead. Hi, Ashley. Okay, Angelica, you said is not here. Tayon. Good morning, Tayon. Akeem Richards. Hi. Craig Ricketts. Craig. Giovanni Rowe. Hi, Giovanni. Devonley here. And Najee Waddell. Okay. Okay, I'll give you a few more minutes. Finish this up. Okay, I think we can work on this together. This is a little bit different because it's what we call an incomplete quadratic. There's no x term, but we're going to work it out exactly the same way we did before. We're going to write down what our A, our B, and our C is. Remember, we have to have y equal and then everything on the other side. When we're dealing with a quadratic equation to graph, that we want to get the y alone on one side and everything else on the other side, it actually is in that form. And the coefficient of the x squared is 1. There is no x term, so the b is 0. And the c is -9. So my vertex is going to be, if I want to find what the b is, what the x is, I'm going to do x equals -b over 2a. Notice those numbers are right handy over here because that's why I like to write them down. It's -0 over 2 times 1, and -0 is just 0, and 0 over anything is 0. In other words, the vertex, the x value of the vertex is 0, and the y then is going to be 0 squared minus 9, because we replace the x with 0, which gives us -9. My vertex is the point 0, -9. It happens also to be the y-intercept, because I know when the x is 0, the other number is the y-intercept. This parabola actually has its vertex on the y-axis. So we've actually accomplished 2 things. We found not only the vertex, we found the y-intercept. To find the x-intercepts, we set our y equal to 0, and that gives us 0 equals x squared minus 9. And we could do this either by factoring or by bringing the 9 to the other side. It's easy to factor to x plus 3 times x minus 3. And if we set them equal to 0, when we set x plus 3 equal to 0, we get x equals -3. And when we set x minus 3 equal to 0, we get x equal to 3. Otherwise, you could have just brought the 9 to the other side. And if you have x squared equals 9, it means that x is plus or minus the square root of 9, which is plus or minus 3. Either way, you get plus or minus 3. So here's what your graph is going to look like. My vertex is at the point 0, -9. My one x-intercept is at -3, 0, and the other one is at 3, 0. So here's 1, Here's 3, 0. And here's what my graph is gonna look like. Remember, I know it's a U shape. Actually, this should be going more further out. Not going to come back in. But we knew it was a parabola because we had a plane y and we had an x squared. We also knew that since the a was a positive number, it would be a parabola opening up. It would be a smile type of parabola, and that's exactly what our shape came out to be. I hope everybody was able to do that. Okay, so that takes care of one of the types of shapes we get when we have a quadratic equation. I told you there really are 4 different types of shapes. Those shapes are actually called conic sections. I'll explain probably after I finish the whole discussion. I'll explain where that term comes from. It really doesn't matter. It's like we call the graph of a first degree equation a linear equation because it gives us a shape of a line. The graph of a quadratic equation, something that has a square in it, will be what's called a conic section. Now I want to talk about the next type of conic section. We talked about one, it's called the parabola. The next type of shape that we can get when we have a quadratic equation is something called a circle. Erase the circle. So this is our next conic section. We already talked about the parabola. Now we're going to talk about the circle. Everybody knows what a circle looks like. What's important about knowing what do you need to know about a circle? Well, a circle is round and it has a center, and all the points on the circle are the same distance away from that center of the circle. This. I have to deal with my diagrams, which are not so perfect. The distance from the center to the edge of the circle is called the radius. The feature of a circle is that no matter where you go from, if you start at the center of the circle and you go to the edge of the circle, you'll always be going the exact same distance. That's what gives it this round shape. And think about it. If I can tell you where the center of the circle is and what the radius of that circle is, then you could for sure draw that circle because you have all the important information. The important information about a circle is its center and its radius. I want to now discuss what does the equation of a circle look like and how do we find the center and the radius. So I'm going to do this in 2 steps. I'm first going to talk about the very simplest types of circles. Just like we can talk about the simplest kind of line is like y equals x. It goes through it. The simplest type of circle is a circle where the center is at the origin. And it turns out that the equation of that circle is x squared plus y squared equals r squared. I'll give you some examples and I'll tell you what the R stands for. But the first thing you should notice that the equation of a circle is very different than the equation of a parabola, because not only does it have an x squared in it, it also will have a y squared. It turns out all the other three shapes, aside from the parabola, not only have x squareds in their equations, they also have y squared. Of course, that makes them a quadratic equation because they have a square, but they have two squares. They have a x square and a y square. Now, this number on this other side that I'm calling r squared, this is actually a number. In other words, I could have something like this: x squared plus y squared equals 16. In this case, my r would be equal to 4 because 4 squared is 16. That number is the radius. That's why I'm calling it r squared. The center of this circle is going to be at the origin. So we know exactly, remember I told you, in order to have a circle, you need two things. You need to know where its center is, and you need to know what its radius is. In this case, if I have x squared plus y squared equals 16, and this number always has to be a positive number because it has to be something squared, we have a circle whose center is the origin. Remember, the origin is right here at the point 0, 0. That's what's called the origin. And the radius is 4, which means it goes out 4 in every single direction. So if I want to graph it, I'm going to call 4 on all 4 directions: 4 up, 4 to the right, 4 down, 4 to the left. I can put in actually what these numbers are. This is the point 0, 4. This is the point 4, 0. Remember, these are intercepts. This is 0, negative 4. And this is negative 4, 0. Those are the 4 places where the circle will cross the x and the y axis, the intercepts. And then just connect them. Don't connect them with straight lines. This is a circle, and here is your circle. So it's very easy when you have an equation that says x squared plus y squared equals a number to figure out what that is going to look like. It's going to be a circle, and the radius is going to be the square root of this number. If I tell you I have a picture of a circle whose center is at the origin, but the radius is 6, for example, then the equation of that circle would be x squared plus y squared equals the 6 squared, which is 36. So my equation is x squared plus y squared equals 36. So I can write the equation of a circle, and I can draw the circle by going to its center and then counting whatever the radius is in all 4 directions, and then just doing my circle. Not every circle has its center at the radius. Not every circle has its center at the origin. What does the equation of a circle whose center is not at the origin look like? Okay, so let's talk about this. Center is someplace else. A little bit more complicated. Let's say the center is the point A, comma, B. I'll give you specific numbers in a second. And let's say the radius we'll call it R. Then the equation of the circle looks like this. X minus a squared plus y minus b squared equals r squared. In other words, instead of just having a plain x squared, you take the x minus a and then you square it, which means, of course, you're going to have an x squared. And with the b, you do y minus b squared, and then that equals r squared, just like we did with the regular circles. So let's first, let me give you an example like that, and I'll draw it, and then we'll go vice versa. First, I'm going to give you, let's say I have x minus 1 squared plus y plus 2 squared equals 25. And I give you this equation. Now, I'm going to tell you it's the equation of a circle, but you should recognize on your own that's a circle, because here you have what you need in a circle is both an x squared and a y squared. And when you have it, if you have just an x squared and there's no y squared in your equation, then it's not a circle anymore, it's a parabola. So we're going to have to be able to look at these equations and tell what kind of shape we're going to get. In this case, this is going to be a circle because I have an x squared and I have a y squared. Now, its center is not at the origin, because the center, because this has numbers inside the parentheses. So what will the center be? Well, we said when the center is AB, we got x minus a and y minus b. Notice this number and this number are opposite signs. In other words, when you want to find the center of the circle, you look at, for the x, you look at the number that's inside the parentheses with the x and change its sign. It's going to be a positive 1. And to find the y value, you look at that number inside there. Again, if there's no number there, it means it's 0. So that means it's like, really, I could have taught this all as one thing without doing the separate origin. But in this case, I have y plus 2, which really means y minus negative 2. The y of the center is negative 2. So switch the signs. This becomes a positive 1. This becomes a negative 2 because you're doing x minus a and y minus b. And y plus 2 really means y minus negative 2. So therefore, I switch the signs. So now I know the center is at the point 1, negative 2. And the radius, well, this is r squared. The r squared, the radius squared is 25, so my radius has to be 5. Notice I can just look at the equation of the circle and tell what its center and what its radius is. So therefore, I can draw my circle. How do I draw the circle? I start out finding the center, 1, negative 2, which means 1 to the right and 2 down. Now, this is, you really have to do this on a piece of graph paper. I think, I see you're not going to see this. I'm going to move over there where there's more room. See if I can show this more clearly. Okay, here's my point 1, negative 2. This is my center. So if I wanted to graph it, I have to go 5, because my radius is 5, in every direction, not from the origin, but from the center point. I have to go 5 up. Now, this is easy. If you want to do it, you really should be doing it on graph paper. Unfortunately, I don't have a graph board, so I'm going to have to use my imagination. But remember, there are lines going up and down and across, and I can count the boxes. So I have to count the boxes from 1, -2 in 4 directions. 5 up, 1, 2, 3, 4, 5. That's 1 point. 5 to the right. 1, 2, 3, 4, 5. 5 down. 1, 2, 3, 4, 5. And 5 to the left. 1, 2, 3, 4, 5. Again, it's easy to do on a piece of graph paper, but notice where I'm counting from. I'm counting from where the center is located. And here's my circle. So again, the only difference between this and the one before is the location of the center. The center is given by the numbers that are in the parentheses. The X number of the center is in with the X, the Y number of the center is with the Y, but notice they're opposite signs. It's a +1 and a -2. And that means that if I were to tell you that I have a circle, let's say I described a circle. Suppose I tell you that I have a circle whose center is the point 5. Let's do this. -5, 2, and the radius is 3. I could tell you what the equation should be. First of all, I could certainly graph it because I could just go to my point -5, 2, and then count 3 in all 4 directions. So I can graph it. But I can also talk about this equation because the equation is going to be x minus -5. So it's going to be x plus 5. Don't forget that square on the outside. Plus y minus 2. Again, that square on the outside equaling 3 squared, which is 9. We can do this either way. We can start out with the equation and look at it and decide what its center is and what its radius is. Or vice versa, I can start out with the center and the radius of the circle and write the equation of the circle. Okay, I'm going to give you one to try on your own. Suppose I tell you, I'm going to give you an equation, and you're going to tell me what the center and the radius of that circle are. I have to sort of erase this because I need some space. But I'll leave this on, the general equation. I want you to tell me what is the center and what is the radius of this circle. I'm going to give you a couple minutes to try that on your own. Okay, I see Abba has come up with an answer. So I think we can look at this problem and see if he's right. Remember, to find the center, we have to look at the numbers inside the equation, inside the parentheses. Inside the parentheses with the x, there's a 1. So the x of the center is -1. Inside of the parentheses with the y is a +3, so we change the sign. So the center of that circle is the point -1, -3, which is what he said. And the radius, this is r squared, is we have to take the square root of this because this is r squared. The radius is 8, and he said that as well. So we were able to figure out the center and radius of the circle from the equation. Just one other word. If I would have given you something like this, x squared plus y minus 2 squared equals 4, let's say. And I asked you, what's the center of that circle? There's nothing, the x is not in the parentheses. That's because we didn't add or subtract anything to the x. So the x center is 0. The y center, well, we have y minus 2, would be a +2. And the radius is also 2 because the square root of 4 is 2. But don't forget, if you have just the letter squared without anything added or subtracted from it, it means that the center there is 0. I want to do one other type of problem, and then I think we can finish for the day. It's also about the circle, which will leave us for Tuesday the 2 other types of shapes we can get when we have a quadratic equation. We're going to look at those on Tuesday. So far, we've done 2 types of what we call conic sections, the parabola and the circle. Now, sometimes what happens is you get an equation that looks like this: x squared plus y squared plus 2x minus 4y equals 4. What happens if what they did to the equation is they removed the parentheses? In other words, they took the x minus a and they squared it. And then they did the y minus b and they squared it. And they collected all the like terms, etc. And they got something like this. You would know this is a circle because you have this x squared and y squared term. A 1x squared and a 1y squared, that always indicates that what you have is a circle. But it's not in the standard format of x minus a squared and y minus b squared equals r squared. I can't tell you what the center of and radius of the circle is because it's not in the right format. And in order to get the center and the radius, what we have to do is go from this, what I would call simplified version of the equation, put it back into the original standard format. And it involves a little bit of a trick, but once you know the trick, it's not hard to do. The first step is to rearrange things. Get your x terms together. So we have the x squared and the 2x, and leave a space. Then get the y terms together. Well, we have a y squared and a minus 4y. And again, leave a space. And if there are any plain numbers that don't have x's or y's, anything that doesn't have a variable with it has to go on the other side. Well, the 4 was already on the other side. So that's the first thing you do. And then we're going to do something that we have done before. That's called complete the square. Make each of these expressions into a perfect square by adding the missing number. And we even know what the missing number is going to be. I'm going to do it. I like to do it in red, but I don't think it shows up enough. Remember, when we complete the square, let's do first the x part. We have the x squared. We look at the number in front of the x. The coefficient of the x is 2. We divide it by 2, so we get 1. And we multiply that number by itself. 1 times 1, and we get plus 1. In order to complete the square on the x's, I have to add 1, because then this will be a perfect square binomial. It will be the expression x plus 1 squared. But notice, I added 1 on this side of the equation. Well, we know we can't do that unless we add 1 on the other side as well to balance. But now I have this as x plus 1 squared. I'm going to do the same thing with the y's. I'm going to complete the square on the y. How do I do that? I take half of the number in front of the y, which is, well, half of -4, don't forget that negative, is -2. And I multiply that by itself. -2 times -2 is plus 4. I'd have to add 4 to these two terms to get this into it as a perfect square expression. This becomes y minus 2 squared. But of course, I added 4 over here. So now, let me do this as a squiggle. Add 4 over here. So we've done this, we completed the square on the x's, balanced. We completed the squares on the y's, we balanced. And now we have the x plus 1 squared plus the y minus 2 squared. And if I add those all up, I get 9. And now it's in the standard format of the circle. So I can right away tell you that the center of this circle is the point -1, +2. And the radius of the circle is 3. Notice it looked originally like the radius should be 2, but it's not, it's 3 because we couldn't make the decision until we had our equation in standard format. So we can get it into standard format by completing the square. So even if we don't ever use the completing the square method to solve quadratic equation, it certainly came in handy here to find the center of the circle. Okay, I'm going to give you one to try now and see if you can do that example. Okay, so here's a question for you to do. Okay, I want you to figure out the center and radius of this circle. We have x squared plus y squared minus 4x plus 6y plus 4 equals 0. We know it's a circle because we have an x squared plus a y squared in the equation. We have both the x and the y have exponents of 2. The coefficients of the x squared and the y squared are both 1. That makes it a circle. See if you can put this in standard form so that you can tell me what is the center and what is the radius of this circle. Okay, I'm giving you a few minutes to try that on your own. Okay, we already have somebody who has an answer. I'll give you others a couple of minutes. It looks right to me. Okay, I think we can work on this together. Again, we know we have a circle. We want to put it in standard format. We get the x terms together, so we get the x squared and the minus 4x, and we leave a space. Then we put the y terms together, so we have y squared and 6y plus 6y, and we leave a space. And this 4 we're going to bring to the other side because we want only the x's and the y's over here. And now we're going to complete the square. On the x, we're going to take half of the number in front of the x term, which is -4. Divide that by 2 gives me -2. And multiply by itself, -2 times -2 is +4. So I have to add 4 to both sides. And this becomes x minus 2 squared. Remember, the number that goes inside the parentheses is half of this number. Then we go to the y. Again, we're going to take half of this number, which is +3. And we're going to square it. 3 times 3 is 9. So I'm going to have to add 9 to both sides. And this becomes y plus 3 squared. And when I add -4 plus 4 plus 9, I get that my equation comes out to be x minus 2 squared plus y plus 3 squared equals 9. I now have it in standard format. So the center is, the opposite of this is 2, and the opposite of that is -3. My center is 2, -3. And remember, the radius now is the square root of this number, which is 3. So now we can look at the equation of a circle, and we can find its center and its radius. Of course, if I wanted to graph it, then I would go to the point 2, -3, and count 3 in all 4 directions so I can get my circle. Okay, so that leaves us with the 2 other types of quadratic equations we could have when we have what kind of shapes we can have when we have a quadratic equation that we want to graph. Okay, I'm going to say have a nice weekend. If anybody did not get to do the test on Delta Math, make sure you can still do it, but you're going to only get 90% of the credit. You get late credit. If you had any problem doing it, you can always email me, and if you if you have a good excuse, I'll give you extra time.
Wait, Professor, isn't it due 8 p.m. tonight?
No, it's at 8 a.m.
You sure?
I'm pretty sure. Did I say at 8 p.m.?
The website says 8 p.m.
Okay, you know what? I will change it to 8 p.m. to make sure if it says 8 a.m. I'll give you to 8 p.m. tonight.
All
Okay,
right.
I'll go and
Thank you.
I can always do that. I thought I put 8 a.m., but it might have been 8 p.m. You're right. I don't know what I did at this point. But make sure it gets finished on time. Okay, by 8 p.m. All right, everybody, have a good day. Have a nice weekend.
You too.
Have a
Bye-bye.
good weekend.
Bye-bye.